This time we'll use the strategy of multiplying by the conjugate. If you recall, the conjugate of a binomial has the same terms, but has a different operation. The plus will change to a minus. So I'm going to take the fraction and multiply it by its conjugate. 1 plus cosine theta turns to 1 minus cosine theta. But of course, if I'm going to do something to the denominator of a fraction, I have to do it in the numerator as well. 1 minus cosine theta divided by 1 minus cosine theta is equivalent to the number 1. When I multiply something times 1, that makes it the value the same, so that makes it legal. When I distribute the 1 to the 1 minus cosine, it remains 1 minus cosine. When I FOIL my conjugates, the 1 times 1 is 1. And as you remember from conjugates, the outsides and the insides will eliminate each other, so we can go straight to last. Cosine theta times negative cosine theta is minus cosine squared theta. At this point, I don't look like I'm any closer to solving this identity. So what I do notice is that 1 minus cosine theta is equivalent to sine squared theta. Still not getting to what I need. I do notice that since this has 2 terms, I'll split mine into 2 terms. Looking better now because I do notice that cosecant squared theta and 1 over sine squared theta are equivalent. So I'll change my 1 over sine squared theta to cosecant squared theta. On this one, I have 1 term, and here I need 2 parts. So what I'm going to do is a little trick. I'm going to take the cosine and put it under one of the sines. So you notice it's squared, so I really have 2 sine thetas times, I have another sine theta in the denominator, so I'll put a 1 on top. If I multiplied this, it's equivalent to what I have here. So now we have cosecant theta divided by sine theta, which is going to give us our cotangent theta. 1 over sine is equivalent to cosecant theta. Whoops. We're going to leave this because that's already what we needed. This is very close to this, but to be exact, we'll use the commutative property, which says I can turn multiplication around into a different order. Therefore, I have now successfully made the left side equivalent to the right side.